Have you ever wondered if a machine could think? It's a fascinating question, and people have been asking it for a very, very long time. This wasn't something that just popped into our heads with the invention of computers. No, this idea is ancient. We can look back to the stories of the ancient Greeks. They told myths about Hephaestus, the god of invention. He was said to have built amazing things like golden robots that could walk, talk, and even think for themselves. These weren't just simple tools, they were imagined as helpers with minds of their own. It shows us that the dream of artificial beings has been with humanity for thousands of years, long before we had the technology to even try to build one. These early stories were all about imagination. They were science fiction before science was even a thing. Think about Talos, a giant bronze man who was said to guard the island of Crete. He was an automaton, a self-operating machine created to protect people. These myths explored the big questions we still ask today. What does it mean to be alive? Can we create life? What happens if our creations become too powerful? These are not just fun stories, they are the very first thought experiments about artificial intelligence. They laid the groundwork for future thinkers and inventors, planting a seed of possibility in our collective minds. Of course, these were just stories. No one in ancient Greece was actually building a thinking robot out of bronze and magic. They didn't have electricity, computer chips, or code. But the ideas were powerful. They separated the concept of a body from the concept of a mind. They imagined intelligence as something that could, in theory, be put into something that wasn't human. This separation is a key concept in modern AI research. The ancient dreamers gave us the what if, and it would take many centuries for science and technology to start figuring out the how. It's a great example of how our imagination often runs way ahead of our abilities. So, the journey of AI didn't start in a lab with scientists in white coats. It started around a campfire, with storytellers spinning tales of mechanical men and intelligent creations. These myths were the first blueprints, not for building a machine, but for building an idea. They sparked a curiosity that would simmer for centuries, waiting for the right tools and the right minds to come along and turn this fantastic dream into a scientific quest. The desire to create an artificial mind is deeply human, and its roots are buried deep in our history and our stories. Consider this. Science is all about exploring the world, and these stories were the first explorations of a world with AI. Fast forward through many, many centuries, we get to the 20th century, a time of incredible invention. People were building the first real computers. These were huge machines, filling entire rooms with clicking relays and flashing lights. They were designed for crunching numbers and solving complex math problems, not for thinking like a person. But some brilliant people started to look at these machines and ask a bigger question. Could these number crunchers do more? Could they one day learn, reason, or even have a conversation? The dream of the ancients was about to meet the reality of modern technology, and things were about to get very exciting. One of the most important people in this story was a British mathematician named Alan Turing. He was a true visionary. During World War II, he helped crack secret codes, but his mind was also on the future of machines. In 1950, he wrote a famous paper and asked a very simple, very powerful question: can machines think? This question pushed the conversation from fantasy into the realm of science. He knew that defining thinking was tricky, so he proposed a clever experiment to get around it. This experiment would become one of the most famous ideas in all of computer science. Turing called it the imitation game, but today we know it as the Turing test. Here's how it works. A human judge has a text conversation with two unseen participants. One is a human and the other is a machine. The judge's job is to figure out which is which. If the judge can't reliably tell the machine apart from the human, then for all practical purposes, the machine has shown intelligent behavior. The test wasn't about whether the machine really thinks like a person inside its circuits. It was about whether it could imitate human intelligence so well that we couldn't tell the difference. It gave scientists a goal to aim for. Just a few years later, in the summer of 1956, a group of scientists gathered for a workshop at Dartmouth College. This event was a huge milestone. It was here that the field officially got its name. A computer scientist named John McCarthy proposed calling their new area of study artificial intelligence. The name stuck. The people at that conference were incredibly optimistic. They believed that a machine as intelligent as a human being was just a few decades away. They laid out a roadmap, dreaming of computers that could use language, learn from experience, and solve problems just like we do. The modern age of AI had officially begun. After the Dartmouth conference, there was a huge wave of excitement and funding for AI research. Scientists were full of confidence. They promised amazing things were just around the corner. Machines that could translate languages perfectly, robots that could see and understand the world, and computer programs that could diagnose diseases better than doctors. In the early days, they had some impressive successes with simple problems. They created programs that could solve algebra word problems and prove theorems in logic. To the outside world, it looked like they were making incredible progress toward creating a true thinking machine. The future looked bright and full of intelligent robots. However, the big promises were much harder to deliver than anyone expected. The real world is messy and complicated. A computer might be good at a logical puzzle in a closed system, but it struggled with the common sense needed for everyday tasks. Understanding language, for example, turned out to be incredibly difficult. A sentence that is simple for a human can have many hidden meanings that a computer just couldn't grasp. The researchers began to hit a wall. The computers of the time were just not powerful enough, and the theories were not advanced enough to solve these complex problems. The early optimism started to fade away. This led to a period that researchers now call the AI winter. Starting in the mid-1970s, governments and companies grew disappointed with the slow progress. The grand promises hadn't come true, so they cut back on funding for AI research. It was a tough time for scientists in the field. Without money and support, many projects had to be shut down. Progress slowed to a crawl. The public perception of AI shifted from excitement to skepticism. The idea of thinking machines started to seem like a fantasy once again, something for science fiction movies, not for serious science labs. Another, shorter AI winter would happen again in the late 1980s, but even during these cold winters, the work didn't stop completely. Dedicated researchers kept pushing forward, often with very little support. They learned important lessons from their failures. They realized that creating a general human-like intelligence was a monumental task. Instead, many started to focus on narrower, more specific problems. They began developing expert systems, which were AIs designed to be specialists in one particular area, like identifying minerals or configuring computer orders. This shift in focus was crucial. It laid the groundwork for the next big breakthroughs, proving that even a long, cold winter can be followed by a spring of new ideas and growth. The 1990s brought a thaw after the AI winter. Two big things happened. First, computers became much more powerful. Thanks to Moore's law, the processing power available to researchers skyrocketed. Second, new ideas and huge amounts of data became available. Scientists began using new techniques like machine learning, which allowed computers to learn from examples instead of being programmed with rigid rules for every single situation. This was a game changer. One of the most famous moments of this era came in 1997 when IBM's supercomputer, Deep Blue, defeated the world chess champion, Garry Kasparov. It was a huge public demonstration that AI was back and more powerful than ever. The 2010s were when AI truly exploded into the mainstream. The combination of even faster computers, especially powerful chips called GPUs, massive data sets from the internet and refined machine learning algorithms created a perfect storm. AI started doing things that were once considered impossible. It could recognize faces in photos, understand spoken commands, and translate languages with surprising accuracy. This wasn't the general all-knowing AI of science fiction movies, but a more practical, specialized AI that could be incredibly useful. Companies like Google, Amazon, and Facebook began pouring resources into AI research, and the results started showing up in the products we use every day. Think about your life right now, on June 8th, 2025. AI is all around you. When you ask your phone for directions, that's AI. When a streaming service recommends a movie you might like, that's AI. The spam filter in your email, the smart assistant in your home, and even the systems that help doctors analyze medical scans, it's all powered by artificial intelligence. It has become a quiet, invisible, but essential part of our modern world. We've gone from ancient myths about bronze giants to real, practical tools that help us in countless ways. It's a remarkable scientific journey that has transformed our society. So what's next? The story of AI is far from over. In fact, it feels like we're just getting to the most exciting chapter. Researchers are now working on large language models that can write code and create art. They are building more capable robots and developing AIs that can make new scientific discoveries. There are still big challenges and important questions to discuss about safety, ethics, and how AI will change our jobs and our world. But one thing is for sure, the ancient dream of creating an intelligent machine is no longer a myth. It is a modern marvel that is continuing to unfold right before our eyes. And that's science.